picking up where that other video left off, you know, my planes are still defined and I still have those toolpaths I showed, but we want to add some turning operations. So what I'm going to do is I'll just throw in a turning operation at the end, and we can always, you know, drag and drop and rearrange things as we need to. I do want to make sure though that my stock setup is defined correctly, and also chuck jaws if I have any. So before I get into anything, I'm just going to grab a cylinder, and I think I might have some inch to metric issues doing this here, but let's see if I can just select this diameter and get lucky. And so 31 millimeters with a length. I'm not sure how well that works, but I guess I'm just going to have to approximate this length. So my plane seems wrong. So there's a little bit of figuring out as far as getting the stock to fit in the right location. My issue comes from this Mastercam front plane being my stock plane. I'm going to grab our plane that we made before. And let's try that again. So cylinder 31.5. So now you can see this gray outline showed up where you know, it looks a little bit more like my part. Tell it. Okay, so it's starting at my Z0, so I want it to go positive Z, and you know, you can basically set your length to whatever works here. Okay, so my length goes over the end of the part. My diameter I'll even beef up to say 35 millimeters, and you know, at the same time, and I'll have it start at -5 or something like that, just so that my whole part is enveloped in stock. It really depends on how you're going to process this. So now I've defined my stock, and I'm going to define some chuck jaws, basically filling out these dimensions to match, so 35 millimeters diameter, and I'm going to grab the part at say Z 40 millimeters. And so you see a live preview of where our chuck jaws go, just for verifying against. And just remember that plane has to be the same plane that we create. That makes, you know, sense for a turning machine. So now I'm going to grab a lathe toolpath, pick a roughing toolpath. So I'm going to select a solid body here, and below this in Mastercam we have chaining options, where I actually want to take this model and spin it, so I can create a turn profile by spinning this part. We could also take a slice through it, but you know, if we took a slice through this part, the profile it creates might not be perfectly correct. You know, you can tell it to ignore individual faces, ignore a back face. We want to make just the upper profile. And so what it means by upper profile, you'll see here. So this is the upper profile. By telling it to ignore the back face, we told it to ignore the vertical line here. But obviously, we aren't going to be able to turn all of this in one setup. So what we can do is we can take the endpoint and move it back. So now we can just run, you know, a roughing operation up to this point. So I'm going to check this, grab a roughing tool. So as far as lathe tools go, there's lots of possibilities, but I'm just going to run through and just pick some default cutters. And I'm not exactly very good with lathe feeds and speeds, let alone metric lathe feeds and speeds, so I'm just going to leave these as they are for now. So we have some options for taking depth cuts and roughing. So say, 1 millimeter max depth cut. stock to leave, an extension for the exit and entry. We want to tell it that it's an OD. So here's the OD ID, front face, back face. I want to use my stock for my outer boundary, so that's just telling it I'm roughing out using my stock. So let's just go with this quick. So you can see it generates a pass. So my roughing depths might have been a little bit light, but it shows what the roughing pass does. So with back plot, so you know, it looks pretty good. However, well, it looks like I'm okay. So my cutter stopped, you know, at this face, and I do want it to go a little bit farther, but without touching these jaws. So there's a couple things I can do. You know, I can give it an exit amount, say 3 millimeters. Maybe it was a lead out actually that I want to do. Once it's done generating. So yeah, so see that exit amount actually was a vertical direction. So let's go back to 0 there. The lead in, lead out was what I want to do. So for lead out, I want to extend the end of my contour by 3 millimeters. So now you can see our stocks live preview ended up, you know, at the end of the part. So now when we can flip this part over and turn the backside, we will have a nice clean face to cut up to. And what I'm going to do next is I'll just do the same kind of process with a finish pass. So I'll grab the finish cutter or a finish tool path, select this body, tell it to ignore the back, spinning profile, upper profile, and same thing, move my endpoint back. Grab a finish cutter, so there's different cutter for the finish passes. We can basically have it take multiple finish passes if that's the case you want. Leave 0 stock. My lead out, again, I'm going to extend it, you know, 2.5 maybe, so I don't rub my finish cutter into my roughing material. Bad idea. I wouldn't last out here. And now you can see, actually our live preview shows the cusp where our finish cutter ended up. So if I just backplot through this, backplot through that, you can see nice predictable result there. So what I want to do next is actually move these operations up before my milling ops, which makes them dirty for some reason, but doesn't affect them. I'll just regenerate. So regenerate the rough, regenerate the finish. I should have just, you know, honestly made my toolpath start up there. So now that I've, you know, put those operations back up top here, if I just wanted to backplot through this whole process, you can kind of see I'm going to rough. Finish pass is a nice quick little finish pass. Goes into my milling and my depth cuts. Contour ramp. So I believe I'm ready to post this out. Obviously, you know, there's going to be little tool paths you want to add in probably for, you know, cleaning up some corner radii or, you know, things like that, but the process is here. So I'm going to click post. So one issue I have here is my machine definition was actually not navigating to the correct folder for post processor. So what I'm going to do is, so you want to check inside of your public documents, shared Mastercam for SolidWorks 2017, lathe posts. These are the post processors that I currently have access to. You may have a post that is, you know, better suited for your machine. Here I'm just going to assume it's a Haas, you know, ST 4-axis lathe. Post. Just give it a place to save the NC file to. Just save it to my desktop. So those errors I was getting, I believe, were actually caused by my settings in here. It is important to tell the machine that it is a y-axis lathe. So I'm just going to make sure those are set to reflect the y-axis. So those ops are still good, so let's try to post out all that once more. There we go, so no errors that time. So what we were doing was we were telling the machine that it was supposed to mill all this, but without using the y-axis, which is impossible. So there's your posted code. Just make sure you have all our tools in here. So there's tool 1. So there's our bullnose end mill. And our smaller end mill for cutting the ramp.